Hello, we are going to look at 11.2, Introduction to Vector Algebra. So let's suppose that if we have a vector and it looks something like this. Let's say it's a vector like this. We'll call this vector v, right? Good. So if that's vector v, then starting at the origin here, where this is O, right? And then we can see if we drop a perpendicular line right here, and we'll say that the distance from here to here, it is distance A, and this is B, right? The way that we represent these vectors, we can say vector v, then, is we call this, this would be our distance A that it traveled here, and then B is our vertical distance up. And this right here is what we call our column. This is our column vector, right? Where this is our A distance, and this is our X distance, how far we're moving horizontally, and this is how we're moving vertically. And these right here, what we call these parts right here, are our components. So when you hear me refer to the components, you know I'm talking about these are my components, are my X distance, how far I'm traveling in my horizontal distance, and my component B is traveling in the B distance. Good. Now, we also have another way that we represent vectors, right? And we're going to go ahead and define our vector I, and these are going to be called our unit vectors. These are our unit vectors, are defined this way. So we use the letter I, and in your book it'll be highlighted, like you'll see some vectors. You'll never see, I'll never write this, we'll just know that I is our unit vector, and it's just our unit vector going one distance, and our X, it's a distance of 1, 0. That's what I would stand for, the unit vector going one unit in a horizontal direction, right? And it's a unit vector because it's one unit. And then we have J will be the unit vector 0, 1, just like this. So that's just going up one unit of a direction, right? And then we'll have, this is our column vector. Then we can represent, if we use the same vector v, we'll call this is our linear combination. That's what we call it. And we can say that vector v, same vector that we have up here, since it's distance A and B, and that's if we call this a unit vector, we can represent this as AI plus BJ, right? And this is what we call our linear combination. And this is, we're just talking about, just so you know, we're talking about the 2D, two-dimensional plane right here, right? We're going to go over three-dimensional in a little bit towards the end of this video. So, so we have two ways that we represent vectors. We can represent them as a column vector right here, and that's AB, but we can also represent it as a linear combination down here. So that's what that means, right? So let's go ahead, and I want to go over something to help us out with something. Now, let's suppose that we have a vector. Let's draw our x and y axis again right here, and let's say I have the vector just like this, and we're going to call this vector A, B, right? Good. And if you can see, I can, if I take the origin right down here, this is the origin, 0, and if I connect it to here and here, you can see we can use that we went over before. We can represent this vector. We can represent this vector using a vector addition, OB, right? So I can say the vector, let's say OB, right? Vector OB is the addition of vector OA and AB. So this would be OA plus AB, right? And just so you know, these two vectors here coming from the origin right here, these are called our position vectors. because they are coming right. They are actually the position of the point A and B. So OA and OA is what we call our position vectors, right? Whatever that coordinate is, the vector would just be how far over X and how over far Y you would, and you can write them like this, right? So, and there you go. And doing a little bit of algebra here, I can see that AB, right, is the same. If I subtract OA this way, it's the same as OA. I'm sorry, it should be the other way around. I want to write this right. So this would be OB, the position vector OB minus OA, right? So you take, if we were trying this vector going in this direction, the direction is important, we can take, the coordinates of it and subtract them to find out what our AB is from both position vectors. So for example, if I let's say A, let's say a little bit of room up here, if A was the point x1, y1, and B was the point x2, y2, then I can go ahead and write this vector AB down here would be equal to, what would OB be as a vector? That would be x2, y2, right? And then minus OA, what would the vector OA be? It would be x1, y1. Good? So what do we have right here? I know that AB as one vector would be x2 minus x1, and then y2 minus y1, and I can write that vector in space just like that. So, and we're going to use this fact right here just to help us solve our next problem here. So if we look at this example here, and this would be in your book, this is example 7, right? Yep. I'm sorry, it's example 6. Example 6, my bad. So example 6. Good. So it says given points A is -1, 2, and B is 3, 1. Write down the vectors OA and OB. These are our position vectors, right? And the position vectors will just end up being what those points are, but we'll just write them in vector form. So, and they want to write them as column vectors. So OA would be the vector, just whatever those coordinates are. It'd be -1, 2. So that's how I write that as a vector, right? I'd have to go to the left of 1 and up 2 for that vector to get to that point, right? And then OB, right, would be whatever these coordinates are, 3, 1, just like that. And then find AB, and we just, to find AB, we can take the vector B, the position vector B, we have 3, 1, minus -1, 2, and then we can write this as, well, 3 minus 1, that's going to be 4, good, and then 1 minus 2 is -1, so that's that one. Good. So that's how we can find that one. Now, going on to three-dimensional vectors, right? If we had three-dimensional vectors, we usually write the xy plane like right here. So it's kind of laying flat. Think about it as looking into a corner, and then the z direction is going up vertically from your perspective. Think of how we tell students to think of the corner, right? And then we can go ahead and this vector that I have right here, we can call this vector B right here that's coming into space. So I drew this out as best I could so you can kind of see. It's hard to draw three-dimensional spaces on a two-dimensional plane. It's basically what we're doing. So, and this would be our x distance, and we'll call that A. This would be our y distance, we'll call that B, just like we did in 2D, but then we're going to call this our C distance, right? So our column vector, we can write vector V would end up looking like this, would be, as a column vector, would be A, B, C, right? And it tells us our direction. Our components are A, B, C. This would be our x direction, this would be our y direction, this is our z direction. And as unit vectors, we use the same unit directions, but there's going to be instead of 2 dimensions, there's 3. So the unit vector would be 1, 0, 0 for I. That's our x direction. Our j would be 0, 1, 0. But then we have a third dimension, and we call that k, right? I'll draw a little bit better. K, and it's usually lowercase, and it's 0, 0, 1, just like that. And so this is our column vector, right? And here are our unit vectors. Then as a linear combination, I can write vector v as AI plus BJ, and then plus K. I'm sorry, it should be CK is the proper form right here. Should be a lowercase. There you go. And they'll be bold as well, usually in your textbook. So this is how we represent 3D vectors. And it turns out everything is just the same in 3 dimensions too, with finding out what this vector would be being. So should see an example. It says given we have points A 1, 3, negative 1, B 3, negative 1, 1. Write down their vectors OA and OB, which are the position vectors. So it'll just be these points just in as a column vector. So I can say OA, right? Well, that's going to be 1, 3, negative 1. And then OB is going to be 3, negative 1, 1. Good. And then B says express AB as a linear combination of unit vectors for the Cartesian axis. So AB, right, would be our position vector OB, which is 3, negative 1, 1, minus our 1, 3, negative 1, and that's going to come 3 minus 1 is 2, and then 1, that's a negative 4, right? And then 1, that's going to be 2, right? So it's 2, negative 4, 2. Hello, it seems that everything I have here is correct. I've just made a calculation in my notes, so I thought I had made a mistake, but everything here is good. 3 minus 1 is 2. Negative 1 minus 3 is negative 4. 1 minus a negative should be 1 plus 1, which is 2. But they wanted to write the unit vectors as a linear combination right up here. So this is a linear combination. So AB, my final answer written as a linear combination, would be 2I minus 4J and plus, that should be a J, right? And 2K, right? And this is the answer in linear combination. Sound good? Thanks, guys.